Hello, I'm Antonio Terceiro and I'm going to talk about TuxMake and how to achieve consistent and portable Linux builds. TuxMake is a command line and Python library for building Linux. It supports different architectures, toolchains, kernel configurations, and make targets. It's a free software project using the MIT Expat license, and it's created by Linaro as part of TuxSuite, which is a suite of tools and services to help with Linux kernel development. In this presentation, I'll be covering TuxMake 0.17.0. Older or newer versions might be a little different. In this presentation, I'm going to focus on the command line interface, but TuxMake also has a Python API which is documented on TuxMake.org. Almost everything is identical between the CLI and the Python API. When there are exceptions, I'll be saying that explicitly, but in most cases, all the concepts and even the argument names are the same. TuxMake has three facets that we need to keep in mind. The first one is automating common kernel build scenarios so that we can throw away or at least greatly simplify our custom scripts to build the kernel. It also provides curated Qt container images containing toolchains so that teams can use the exact same build environment when discussing and reproducing issues. So by using these container images, you can use an exact version of compiler and tools to build your kernel, and your teammates can use the exact same version on their side. And if you combine the two first points, then we can say that TuxMake enables consistent, portable, and reproducible builds. Getting TuxMake is very easy. There are a few different ways you can do that. You can use pip and install the Python package from the Python package index, or you can install a Debian package or an RPM package that are provided on TuxMake.org. And you can also not install TuxMake at all. You can very easily run TuxMake from the source directory, and it only depends on the Python 3 core, so you don't even need any extra dependencies beyond the Python interpreter. So specific instructions for each of these types of installations are provided on TuxMake.org, and you can check it out for more information. For using TuxMake, there are a few terms we need to be familiar with. So the first one is target, which means a part of the kernel tree that TuxMake knows how to build. For instance, it can be the kernel, modules, DTBs. This is more or less the same as the make targets we are using from the kernel, but in some cases there are slight difference, but mostly is just a common name for part of the kernel. Toolchain is a specific toolchain version, so in this example we are talking about GCC 10 or Clang 12, and when you choose a toolchain TuxMake, then if you are also using the container images, then TuxMake ensures that you get exactly that compiler version. And runtime is how TuxMake will run the build. We have a few options, so the default is the null runtime, which means TuxMake just do the build on your host system using whatever toolchains are available there. And then we have the container runtimes, which is Docker and Podman, which will download the curated container images provided by TuxMake project itself. So if you say toolchain GCC 10 and runtime Docker, then TuxMake is going to download the GCC 10 Docker image and then run your build using that image so that you have the exact same GCC 10 that everyone else using TuxMake gets when they use the GCC 10. Basic usage is very simple. You just run TuxMake in a Linux source tree, and TuxMake will do a build using all its defaults. It builds a default set of targets. You can see in the slide here. So it builds a configuration, it builds a kernel, it builds modules, you build DTBs if that's supporting the architecture you are using. it builds a debug kernel, which is VM Linux with no compression and debug symbols, and it also builds a header starball. And by default, you put the output in a .cache directory in your home directory, but you can also override the output directory, so that's just the default. If you look inside the output directory, you can see there are several files there, which are mostly the artifacts we are interested in building the kernel. So you can see that you get the full build log, and everything that you get as a build log on the terminal, you also get saved in that file. You have the kernel, in this case the image. You have the final resulting configuration file, which is config. You also get a header starball with the headers from the kernel. And you get a metadata file. It is a JSON file that contains several metadata about the build itself, about the build environment, such as exact compiler versions, the version of the tools that are installed. You get statistics about caching. For instance, if you are using Ccache, it will tell you exactly how many cache hits and cache misses you had. You also get modules if your kernel was configured for modules. You get system.map file, and also you get a VM Linux file, which is compressed to save space. So of those, the ones that are always present are build.log and metadata.json. So those are always present independent of what you are actually building, and the others are artifacts from the build targets. So if you can only build the kernel, for instance, and not build modules or headers, and then you don't get modules or headers tarball. Now, going beyond the basics, you can change how TuxMake does your build in several ways. If you want to build a specific target, for instance, if you only want the kernel and not modules or DTBs or anything else, you can do TuxMake kernel, and then you just do that. TuxMake also has support for a few tools from the kernel source. So you can build, for instance, k-self-test with TuxMake k-self-test. And we also have support for perf and CPU power at the moment. By default, TuxMake does silent builds, so you only get warnings. But if you want to have a full log, you can pass v equals on to the command line, and also use the -- verbose, which will drop the -- silent flag from make. So this way you get a full build log. And v equals on is just an example, but you can pass any make variables to the make command run by TuxMake, just using variable equals value in the command line. By default, TuxMake will do a def config build, but you can change that using the -- kconfig and the -- kconfig add options. So -- kconfig allows you to define which is the main configuration you are building. So you can do all mod config, for instance. And -- kconfig add lets you add config fragments on top of that configuration. So it can be both a config fragment directly in the command line, or you can also point to a local configuration file which has your several config fragments you want to enable. For kconfig, you can also point to a local file, so you can store a custom configuration file, or use your distribution configuration file just pointing to it in the command line. You can also build for different architectures using the -- target arc option. In this case, for instance, we can do TuxMake -- target arc equals ARM64, and then TuxMake will handle everything to get the cross-compiling correctly on your side. And in this case, you have to have the cross-compilers installed, but if you use the container runtimes, so with either podman or Docker, then TuxMake will download a container image for you that already has the cross-compiler, and then you get everything with the correct cross-compiler. Using TuxMake, you find that several options are useful, and you want to use them in all your builds. So TuxMake supports configuration files using the @name convention. So when you use a TuxMake add name, then that's going to load a configuration file in .config/tuxmake/name in your home directory. So for instance, you can have a add ARM64 configuration file that sets the correct arguments to do an ARM64 build, and then you don't have to repeat yourself every time. So in this case, the configuration file sets the target architecture to ARM64 and also sets the runtime to podman, so you don't have to care about having a cross compiler installed. It will just get one from the TuxMake images. And there's a special case, which is the default configuration file that's used implicitly on all builds. So if you have options that you want on every single build, then you can store that in the default configuration file, and that gets loaded on all builds. So for instance, here I have, for all my builds, I want to use Ccache as a compiler wrapper to cache compilation results, and I also want always to do a git clean on the source directory after the build using the post-build hook option. Note that this feature is only for the CLI, so if you're using a Python library, you already have complete control on what you do, so you don't need it. So these configuration files are only read by the command line interface. Another configuration that is only for CLI is the hooks, which allow integrating TuxMake in your workflow. So we have three types of hooks. One is the pre-build hook, where you can specify a command to run before the build in the source tree, or a post-build hook, where you can specify a command to run if the build succeeds, then that command will run in the source tree. And then you have a results hook, where you specify a command to run after a build succeeds in the artifact directory. So for instance, you can inspect the produced kernel or the build log from there. For instance, you can check for warnings, or you can check for specific items in the metadata file. And again, this is for the CLI only, because if you are using the Python API, then you already have full control of what you do before or after the build. So one example of workflow integration is using TuxMake to bisect a build failure, and that's more or less trivial. You just start a bisection and you run TuxMake with whatever options you want as a bisection command, and TuxMake does the right thing of exiting of non-zero if the build fails. And then when doing a bisection, you want to pass a few options to speed up things. So you want to use Ccache most probably, and you can also use a custom build here. In that case, TuxMake will reuse the build directory, so you can cache the compilation results using that as well. Now a second example, when you want to bisect a runtime bug. So you can use a results hook and pass a script that's going to be called in the results directory. So for instance, that script can get the kernel you just built and boot it into EMU, run tests. Or the script can copy the kernel and the modules to a VM, do a reboot and run some tests. Or you can submit the build kernel to some online testing services. For instance, for example, you can submit it to Lava for testing. In the future, I want to investigate a few other options to improve developer workflow using TuxMake. The first line of investigation is using TuxMake instead of make as a custom make command in ktest. So that's going to be enabling you building the kernel with TuxMake while using ktest. And that's going to be interesting because you can simplify a lot the actual building of the kernel and then integrate that in a testing tool. And also TuxRun is a tool that we are extracting from TuxSuite's TuxStat service. It will boot kernels from multiple architectures on QEMU and run tests against them. So TuxRun is going to be to TuxTest as TuxMake is to TuxBuild. So just as Tux build is TuxMake as a service, then Tux test is going to be Tux run as a service, and then Tux run will be a free software tool as well, in the same way as Tux build. And also, if you have other ideas of integration, you can talk to me. You can send your ideas as issues or as patches to the Git repository, and they will be very welcome. And that's all I had for today. If you want to talk more about TuxMake after this talk, you can stay for the Q&A session, or you can also talk to us later in the GitLab repository by opening bug reports or merge requests with patches. You can also join us at the TuxMake channel on Freenode. And to learn more, you can go to tuxmake.org, where we have our website and all the documentation.